Welcome. This video covers loops in R. We've really accomplished most of the things that we set out to do in this course. We know how to read in raw data using the readr package for the most part. We know how to summarize and manipulate data. And now we're left with, well, how do I just get better at R programming? And so this module here is going to cover some useful things to help you just improve your R programs. And one thing that we often want to do is just streamline our code. There's often some sort of a repetitive task that must be done, but each time that you run that task, you need to change just a little bit of it. And then you want to run that same task again, but you got to change that little bit again and then do it again. So oftentimes you'll copy and paste chunks of code, just changing one little bit here and there. Well, we don't necessarily want to do that, right? We don't want to have to write that same chunk of code over and over again. Is there some way to streamline this? So the example we're going to look at here is summarizing each column of a data set. We need a data set to actually analyze here or summarize. And so we're going to read in this wine quality data set that we looked at previously. With this, there's a quality variable representing how good the wine was based off of some tasters. There's the type of wine, red and white, and then there's a lot of variables about the chemical composition of the wine. And what we might want to do would be, say, summarize each one of these numeric variables. Of course, R has some really nice functions that are built in that can help us out. Like the summary function here, we'll just take every column of that data set and provide a basic summary for us. And so any of the numeric columns, it gives us the 5-number summary plus the mean. And then down here, the last column, you can kind of see it's that character column that had the type of wine, and that's just going to tell us what values type can take on. So this is great. I mean, this is really useful information, but what if I wanted to do a customized summary? What if I wanted to print out the mean, the median, and then what's called a trimmed mean? A trimmed mean is where we drop off the smallest and largest observations. So for instance, you might talk about a 5% trim mean. And what that means is that you're going to drop off the smallest 5% of observations and the largest 5% of observations, and then find the mean of the remaining values. And what that does is it just helps with having really skewed data or having really big or small outliers, because it's going to remove those ones out there on the edge and then just look at the mean of the ones in the middle. How do I get a trimmed mean? Pretty easy. You can use the mean function, and there's actually an argument for trim. So if you wanted to be more explicit here, this is a trim equal argument here. So this might be a customized summary that we want to produce for each column. I want to produce the mean, the median, and the trim mean. I can certainly do that pretty easily myself, right? So I could do mean, take the wine data set, and then give me the fixed acidity column. Same thing with median, same thing with the trimmed mean. And I'll just wrap that in a vector, right? So I'm going to have a vector of those values. And what we're doing here is we're actually giving names to each bit, right? So we didn't really look at naming these things before, but we're just naming the elements of our vector. All right, that's fine, but if I wanted to do this for every single one of my columns, well, I just would need to change that variable name, right? I have to change this each time that I change the column that I want to look at. And there were, I think, 12 numeric columns in this data set. So am I going to copy and paste this same chunk of code 12 times, just changing that variable name? That sounds awful. That's not something I want to do. And this is where something like a for loop can come in handy. All right. There are a couple different kinds of loops in R. There's for loops, there's while loops, and something called repeat loops as well. Mainly for loops are used, although I do see while loops here and there. So we're just going to mostly talk about for loops. For loops, the syntax for them looks like this. And the idea is that within these curly brackets, the code that's in here is going to be run multiple times. So this is going to run over and over again. And each time that it runs, there's a thing called the index of the for loop. And the index is going to change at each iteration of this loop. So the first time that this code runs, index will take a certain value. The second time it runs, index will change and take a different value. The third time, a different value, and so on. And the values that it takes on are given here in this object, values. So index is the object that's created that's going to change each time. How is it going to change? It's going to change based off of the values that you specify in this argument here. Let's look at an example. So here are two different for loops. Over here on the left, we are calling this index index. And so this is the R object that will change at each iteration. How is it going to change? It's going to change based off of what the values are over here. And remember that 1:10, this creates a vector of 1, 2, 3, all the way up to 10. That means that the first time that this code, or the first time that this for loop evaluates, it's going to evaluate this code and index will take on the value 1. And the code that we're actually evaluating is print index, which means that it's just going to print out that value. And then after that code has run, it's going to come back up here and it's going to go to the next value. This R object called index then changes and takes on the second value. So print index becomes print 2. And it goes through all of the different values that you have over here, and once it's all the way through them, it stops. This gives us a very easy way to repeatedly run the same kind of code. Over here on the right is just another example, except this time I've changed the name of the index. So I, J, and K are very common. So these are just common values to use as that R object. And in this case, it's not going to take on numbers. So that value I, that R object I, is not going to go through numbers, but it's going to go through this character vector. That means that the first time that this code down here evaluates, I is going to take on the value cat. It prints out cat. It's done using that code, so it comes back up to the top. I goes to the next value, dog. It prints out dog. That code's done evaluating, it comes back up to the top. I takes on wolf, print wolf. Comes back up to the top, there's no more values, so it stops running. This is just a way to show you that the index can go through different things. It doesn't have to be numbers, although usually we're going to go through numbers, but you can also go through character vectors, other things like that. Let's just talk a little bit more about the values that you take on. So the values thing that we have over here, this defines which values the indexing variable takes on. You don't have to create that inline. You can create it as an R object previously. So here I've created an R object called values that is a numeric vector of 1 to 10. And I say for index in values. So it's now going to say create a new R object called index that goes through all of the values here in that R object. Similarly over here, a very handy way to create a sequence that goes across the columns of a data frame is the sequence along function. And so the sequence along function just says, I'm going to basically say how long is this iris data frame, i.e. how many columns does it have? And what I'm going to do is just create a sequence from 1 to the number of columns. So in this case, iris is a data set that has 5 columns. And so sequence along creates a vector 1 through 5. And now what I'm going to do down here is I'm going to say, well, in the first iteration, I is going to take on 1. I'm going to look at the names of iris. The names of iris corresponds to the column names in this case. And I want to print out the ith column name. So when I is 1, I want to print out the first column name of iris, which is sepal length. We go back up here. I goes to the next value, which is 2. I want to print out the second column name of iris, and that's sepal width. And again, it goes through all the values in this sequence. Let's see how to take this kind of idea and apply it to our problem of a custom summary of columns. We want to go ahead and print out the mean, median, and trim mean for each one of our numeric columns in our data set, this wine data. This first part here is just going to set up the index and the values that that index is going to take on. So I know that I have 12 columns that are numeric, and they are the first 12 columns of my data frame. And so I'm just going to say, let's let I, my index, take on the values 1 through 12. What we're going to do is at each iteration here, we're going to pull out a particular column. Remember that the pull function comes from dplyr, and it's going to say, I'm going to grab just a certain column and return it as a vector. So it's going to pull from the wine data the ith column. So when I is 1, it's going to grab the first column. And we're going to store that in an object called callData. Then what we're going to do is we're going to go ahead and print out the name associated with that. So I'm going to do the same thing we did with the iris data set. We'll do names of wine data, bracket I. So the first column name will get printed out. And then I'm going to also print out the mean, median, and trim mean of that column of data that we pulled out. All right, that wasn't too bad, right? Let's see what happens. When we run that, we then get this output. we see that we get the column name printed out just like we wanted up here, and then the sample mean, sample median, and sample trimmed mean. And this goes through every single numeric column 1 through 12 that we specify. That's fantastic, right? We saved ourselves copying and pasting this code over and over again. But you know what? This still leaves a little bit to be desired, right? This isn't great because we have printed this stuff out, but we have not saved it anywhere. So we can't use it later if we wanted to use it later. How do we go about, say, keeping this for later use? No problem. The big issue with for loops is that what you need to do is initialize an R object to save the data in or save the results in. So we've got to initialize an object to save our results in. And sometimes that can be a little bit tricky. But in this case, what we really want to do is perhaps save all this information in a data frame. And so what I'm going to do is just create an empty data frame. So I'm going to initialize essentially an empty data frame corresponding to the values that I'm going to have when I'm done running my for loop. So what I'm going to do here is I'm going to create just a variable that knows the number of columns of the wine data set. And then I'm going to create a data frame. We know how to do that with data.frame. I want to store the variable name along with the mean, the median, and the trimmed mean. And we know that we can name our columns here whenever we create our data frame. If you recall that, we just put the name that we want for our column. So we say var name, and then you're supposed to specify what that column should be. Well, in this case, I know the names that I'm going to iterate through. So I'm going to go ahead and just say the names of wine data, which gives me all the column names. And then I want to just drop that last column because I'm not going to summarize the type variable. So var name then spits out these 12 column names. So that's the vector that gets stored here. Then mean, I'm going to initialize just an empty numeric column. So I'm going to use this numeric function. It's just going to create an empty numeric value. Say numeric, and I want it to be of length 13 minus 1, so of length 12. I do the same thing for median and trim mean, and I get an empty, what we would refer to as like an empty data frame that we can now fill with each iteration of our loop. Okay, how do we do that? Well, we know how to access a particular grouping of our data frame, right? We can access a particular row, and we know how to tell it which columns as well. So what we're going to do here is use the same kind of idea. So just like we talked about here a second ago. So I'm going to do for I in sequence along wine data, which will give me a sequence from 1 to 13, except I'm going to subtract out the last value. So that's only going to give me 1 to 12. And now what I'm going to do is, like we did before, pull that wine data column I. So pull the first column the first time, the second column the third, whatever. And now what we want to do is in this object that we created, this initialized object sumDF, in the ith row, in columns 2 through 4, I want to store the mean, median, and trimmed mean. So again, this is the ith row, and this is columns 2 through 4. What we want to do there is just save these values. And so in the first iteration, it's going to save the values corresponding in the first row, second iteration, second row, all the way down to the 12th row. And now I have these values saved for later. I have my custom column summary. I can use this information later in plots or in a table, and I'm good to go. Now, that's the basic idea of a for loop and a good example of it. Like I mentioned before, there are while loops, and those get used a decent amount too. Not nearly as much as for loops though. But the syntax for using a while loop is a little bit different. You do a while condition, and so a condition should be a logical, so a true or false value. And so it might be something like counter less than or equal to, I guess I should write that with R notation. So you might do something like counter less than or equal to 10. And as long as this counter variable is smaller than or equal to 10, this loop will evaluate. It'll come back up to the top, check that condition again, evaluate, come back, check that condition again, and keep going back and forth. And so usually within a while loop, you will have something that will modify your condition. Okay? So your condition might be that the counter is less than or equal to 10. Within your loop, you might do something like, I want to store counter equal counter plus 1. And I should use a storage arrow. So I do counter, store counter plus 1. And so the next time I come up here, counter will grow it'll keep growing until eventually it would be bigger than 10, and that would resolve as a false. And once this resolves as a false, it stops its evaluations and jumps down to the next bit of code that you might have. So again, these are very useful. Basically, though, for loops will get the job done. You don't really need to use while loops if you don't want to. A couple other really useful things about loops that you should know. There's a break function, and you don't actually call it like a function, it's just like a keyword. And so break exits out of a loop. Here, what we're doing is looping from 1 to 5. So I is my index. It's going from 1 to 2 to 3 to 4 to 5. And within here, I have an if statement. We haven't really looked at if statements, but a basic if statement just takes in a condition. And if that condition is true, we evaluate the code in here. So this is a condition. If true, I guess I should use caps here. If true, evaluate what's in the curly brackets. And so in this case, when I is 1, it says, is 1 equal to 4? No. So I'm going to skip that. I'm going to print out I. 2, 3. Once it gets to 4, it says, is 4 equal to 4? That would resolve as true. And then it would run break. And it says, okay, that means I should kick out of this loop. And so it doesn't ever get to 5. It doesn't ever get to 4 when it's getting to this print business. So it does 1, 2, 3, and then skips out. That's a useful mechanism to have when you're doing loops. Another one is next, and next just allows you to skip a particular iteration of a loop. In this case, I'm checking if I is 3. If I is 3, then I want to skip this iteration of the loop. So it prints out 1, it prints out 2, but when I actually takes on the value 3, it skips to the next iteration, so I comes up here and jumps to 4, and now we print out 4 and 5. Let's jump into R and do some looping. Here we are in R. I'm going to create a new markdown document for this section of the notes. We're going to read in that same wine data set that we were just messing around with. I'm going to rename the variables though, so that we don't have any of these non-standard ones. All right, I have this my wine data object. It has 13 columns, 12 of them are numeric, one of them is character. And what we're going to do with our for loops here is try to take this quality variable that's in there, which would represent a response variable for this data set. It's telling us how well the wines are performing. So quality is going to be what we might refer to as a response variable. And we're going to try to use each one of those numeric chemical composition element variables as a predictor of quality. And we're just going to try to fit the best line through that data. So we can do this using the LM function in R. We can fit a simple linear regression model very easily. We'll do LM. You give it the response variable that you want. So I'll do quality. And then I would need to give it which predictor I'd want to use. So for instance, the first one in our list was fixed acidity. And then I just tell it which data set these variables are coming from, and that's the my wine data. If I run that, it fits a simple linear regression model and says that this is the slope for that the intercept for that model, and this is the slope. And if I just wanted to pull out those two values, I could do the coef function. Actually, let me save this as an object first. I'm going to save this object as fit, and then I'm going to do coef on fit, and this function will just return the estimated intercept and slope. All right, so our task here is going to be to run this same kind of code, but each time what I want to do is change that fixed acidity. I want to change that to a different predictor. And that's going to be easy to do using a for loop. So we're going to iterate through our predictor variables using a for loop. First thing we need to do is use for to say we're going to do a for loop. And then we create an indexing variable. Just standard, we'll just use an I. We'll say for I in, there are 12 numeric columns, but the last one is the quality variable. So I'll say for I in 1 to 11, the first 11 columns. We'll go ahead and run this LM code up here. But instead of fixed acidity here, I'm going to go ahead and do pull my wine data. And then we're going to use the ith column, so I'll put an I there. So when I is 1, that's going to pull the first column. When I is 2, it'll pull the second column, and so forth. And then I'm just going to do print coef on fit. And that will print that out to the console. So this is a basic for loop that will cycle through all of these different predictor variables. All right, so I can see here, I got each one of those fits and their sample intercept and sample slope. That's nice, but of course, this isn't ideal. I don't know which variable each one of these is. Again, I haven't saved these anywhere, so I don't have them. let's go ahead and improve this. So we'll improve it by saving results in an object. We'll need to initialize an object. What we're going to want is an R object, a data frame, that's going to have a column for the slope, column for the intercept, and then a column for which predictor. So we'll create an empty data frame that has the predictor values in it as the first column. So we'll say predictor. We need a vector corresponding to that. That'll be the names of the MyWine data set, but not all of them, right? We don't want the 12th or 13th column. So I need to do minus 12 to 13 there. Let's just make sure we understand that. Remember that names of MyWine data, this is just going to give me the column names. And so only the first 11 columns are my predictors. So I'm going to do minus 12 and 13 to get rid of those last two. If we just look at what that outputs, sorry, I need to put parentheses around this. Because it thought minus 12 to 13 had both negative and positive values. Put parentheses around it, it says not 12 and 13. So this creates this column predictor that will be useful. And then we need an empty column for the intercepts and slopes. So we can do that just like we did in the video. So we'll say intercept. That needs to equal a numeric column of length 11. So we'll just do 11. Slope equal numeric 11. So we run that, it fills those in with zeros, and now I'm going to be able to go through, and in each iteration, rather than printing it out, I'll just save it in these two spots. No problem. I do need to save this data frame as an object, so I have it for later. So I'll call this fit coefs. It's going to house the fit coefficients. Sorry, my programming habits. Oh, got to make sure that I keep this looking good. So good programming practices say to drop this down here, not over here. Much more readable code. All right, now I'm going to take that same for loop that we had up here, copy that, bring it down. The only thing I need to change is this part right here. Instead of printing out the coefficients, what I want to do is in the ith row, so the ith row in the second and third columns, I want to store the coefficients of the fit object. And now I can run this whole code chunk. I'll just go over here this time. Run the whole code chunk. And now fit coefs, go ahead and just plop that down here, has the predictor, the intercept, and the slopes all in one nice place. So a very easy application of for loops for fitting a bunch of different simple linear regression models. All right, we're able to improve our code a little bit here. We're able to use for loops to avoid copying and pasting multiple chunks of code too many times. What we're going to find out, though, is that for loops are a little bit slow in R. And so if you have anything that's computationally intensive, you're going to want to use what's called a vectorized function. And so we'll cover vectorized functions next.